5 can be, so for the listening audience that I am now recording, we did say on Friday that 1, 5, and 6 had the same solution, and we're trying to remember, because it's been a long weekend, why they have the same solution. I did, but I don't think I got it uploaded yet. Factoring. Okay, say more about factoring.
So in order to get it, wouldn't you have to get the first saved answer for number 1?
Right, but we don't want to actually have to solve it. Is there some other way that we can tell they are going to have the same solution?
Divide all of them by 2.
Divide all of them by 2. Okay, I like that one. So if you look at equation 5, if I divide everything here by 2, okay, what am I going to end up with? Or yeah, let's say we're factoring it out. I have 2 times 5x minus 4, and that is equal to 2 times x plus 3. And is that the same as anything we already have? Yes, that is the same as number 1. Now, why is that the same? Because you can divide by 2, divide by 2, 2's cancel out, and you end up with the same thing. So they would have the same solution. Okay, so that takes care of 1 and 5. Why did we say 1 and 6 were the same? Somebody else. Why are 1 and 6 the same? Everybody take a look at it up here. I mean, here you have an x, and actually this should not be an x. This is an error. Maybe that will help you. That should be just 3/10 plus x divided by 10 equals 1/2 x minus 0.4. Okay? What am I doing here? Guys, everybody should be looking up here. How can we tell that these two equations, 1 and 6, are the same? Gabe, I need your head up here, please. Sean, up here. Come on. Divided by what?
10.
Yes. Excellent. If I take equation 1 and I divide it by 10 on both sides, I get 3/10, not by fraction, but written as a decimal, plus x divided by 10, that's right here, 5x over 10, 5/10 reduces to 1/2 x, and minus 4/10. Yes. So those are the same. There is one more set that does not involve 1, 5, or 6. Can you find the other one? And this one is a lot harder to find without solving. I'll tell you that. So it involves 2, 3, and 4. Do you see one that is somewhat similar and would have the same solution as another equation out of 2, 3, and 4?
Wouldn't number 4 be the same as number 2?
Okay, why do you say that?
Because for number 4, if you take out the factor of 2,
Uh-huh. So if I factor out a 2, I get 5x plus 3 equals, factor out 2 here, and I get x minus 4. And the 2's would simplify out. 5x plus 3, is that equal to x minus 4? Are those the same? Right. But look, you have 5x plus 3, and you're comparing it to 5x plus 4. So it's one more. Over here you have x minus 4 and x minus 3. So that one extra would fit over there. So yes, 2 and 4 are also the same. It's more helpful here if you try to simplify a little bit. So if I said x minus 3 equals 5x plus 4 and try to get all my variables to one side, again, you have to do a little bit of finagling here. You would get negative 3 equals 4x plus 4 over here. Moving it to the other side, 5x plus 3 equals x minus 4. I guess I need to do a little bit more. Subtract x. You get 4x plus 3 equals negative 4. And if I move the numbers to the other side, you're going to get 4x is equal to, what is that? Minus 3, negative 7. And over here, subtract 4, you're going to get 4x is equal to negative 7. But you had to do a lot more work for this one. Okay? All right. So 1 and 5 are same solutions, and 1 and 6. So essentially 5 and 6 are all the same solutions. And also 2 and 4. 2 and 4. Okay? Any questions on that? Same solutions. All right, now let's turn to page 83. Now we're looking at two different equations again, and we're trying to see, is there something I can do to the first equation to get to the second one? Is there something I can do to get from the first equation to the second equation? All right, so look at the first problem. 7 plus 5x equals 3 minus 2x. Is there something I could do to that to get 7 plus 7x equals 3? Rachel, I'm going to have you take a pause for a minute here. Add 2x. Well, let's see. If I add 2x here and I add 2x here, because in an equation, whatever you do on one side, you have to do to the other, I get 7 plus 7x equals 3. And that is exactly what I have for the second equation. So yes, just add 2x to both sides. So that's a definite yes. Anybody else happen to see that as we were starting to look at it a little bit? Okay, good, good. All right, let's take a look at the second one. So is there anything I can do to this equation to get the second equation? Morgan. Multiply. Okay, say that again. Okay, so if I multiply 3 here, would I also have to multiply by 3 here? Yes, I would. And so that is going to give me 45, which would be too high. So you're kind of right, yes, on the left-hand side, but it's not going to work for the right-hand side, because if whatever you do, if you multiply by 3 on the left-hand side, you would also have to do that on the right, correct? Whatever you do to one side, you'd have to do to the other. So this one then is a no. There's nothing you can do to the first one to get the second one, unless, what could we change? What could we change? Well, I always think that's erasing. No. What could I change about the second equation so it would work? Morgan. Right, and we know what that number is, but what could I change over here so that it would work? Because she said, I want to multiply by 3, and I can't now, but how could I change that second equation? How could you change it? No, I don't want to divide. Yeah, if I change this 15 to a 5, and then I multiply by 3, then that would give me 3 times the x minus 4 equals 15, which I'm looking for, and that would work. But that is not what we had, right? So that's not what we had originally. So it's still a no, but now you see what we could do. All right? Very good. Okay, let's go to the third one. X squared is equal to 6 times x. What could I do to that one, if anything, to give me the second equation? Square. Square what?
The x squared and the x.
You want me to square the x squared and the 6x?
Yeah.
So you want me to square it?
No, not square that.
Well, no, okay. So here's where we need to be precise. In math, you always need to be very precise, right? So what do you want me to do?
I was like trying to I don't know.
Square root?
Yeah.
Take the square root. Okay, so if I take the square root here and I take the square root here, the square root of x squared is x. The square root of 6x, I can't simplify that. So is this the same as that? No. But you're right, there is something. I keep seeing all the same hands. I love your hands, but I keep seeing the same ones. I want some different hands. Lynn, how do you say it? Lynn, what can I do? Say it one more time. Multiply what? Multiply x equals 6 times x, which would give me x squared equals 6x. You're right, but we need to do something from the first one. So what would I need to do from the first one to get that? Yes. So you had it right. Yes, they are the same, but the choices were to go from the first one to the second one, you would divide by x. Okay? Which is the same thing. X equals 6. So that's a cha-ching. That's a yes. We can do that. Divide by 6. But isn't that interesting? I mean, she said take the square root. And, of course, taking the square root does get you x for the first part of the equation. It does not work for the second. So that was good thinking, but always check with both sides. Okay? And the last one on this page, we have 1 divided by x minus 5 equals 10, and 1 equals 10 times quantity x minus 5. Imani, head up please. Thank you. What, if anything, can I do to get from the first equation to the second? I see your hand. What do you guys think? She said, wouldn't I have to multiply the bottom? What's another name for the bottom mathematically? Denominator, good. I love when you guys talk math. I would multiply the denominator by how much? Okay. Ah. Ten times quantity x minus 5. Well, guys, did that work? Yeah. This is one that you really need to get accustomed to, because when you have things in the denominator, like a fraction, if you have like 1/2 x equals something and you're trying to solve for x, you want to get rid of what's on the denominator, especially if you have an equation, by multiplying by whatever number is here. Okay, take it out of the fraction form. So by multiplying by x minus 5 on both sides, yes, it cancels out on the left, and over on the right, we get what we have in our second equation, 10 times quantity x minus 5. And then you would have to distribute and solve and all the rest of that. Okay, very good. All right, any questions about any of these 4 problems on page 83? Yes?
Dividing the second one by x minus 5 was
Be the same? Absolutely. Absolutely. The only difference, she said, would dividing the second one by x minus 5 be the same? And it would. The only difference here is it says going from the first to the second. But absolutely. Like if you saw this on a test, yes. Okay? And that would give you the same, which is what we had in the first equation. All right, so just to recall, for the first problem, we just started to simplify a little bit, and that's how we got them both to be the same. And the second one, there was no way that was going to happen unless we changed 15 to a 5, but the original equations are not going to be the same. For the third one, we just divided both sides by x. And the last one on that page, we multiplied by our denominator to get rid of it as a fraction and make it into 1 equals 10 times quantity x minus 5. Any questions on those? Okay. So I'm sorry, that is all I have for today. Homework. You now can work on module 2.1. That's homework number 1. I haven't gotten too many of those, okay? But I think we did talk about that last, I want to say Thursday. Maybe on Thursday. Now you can work on also homework number 2. Remember, all of these are on Canvas, so they are very doable. We do have some extra time now, so if you would like to come talk to me about making corrections or when we want to do a retake, that now would be a good time to do that. Yes? Yes. Is that a question, Caitlin? No? Okay. Any other questions? All right. And of course, we do have our test coming up on September 19th.
Is this in like 2 days?
Is that in 2 days?
Not 2 days, 2 weeks.
The 19th, well, today is the 2nd, so 17 days, just about 2.5 weeks. Okay, so it's probably 2 weeks from Friday. All right, but let's be working on this homework. Again, this is on Canvas. Make sure you're keeping current with the homework, because if you want to do a retake, you have to have done the homework first. Okay? All right.